Hey guys, Mr. Chandler here to go over some projectile basics with you real quick. Let's start off with a projectile that's launched at some angle. It doesn't really matter. Let's make one up. Let's just say it's 22 degrees. How about that? And it's 27 meters a second going up that way. And the three basic things we all need to know how to do is one, right, how long is it in the air for? Two is how far does it go? And three is how high it goes. Right? Everyone needs to know those three at a minimum to know how to do those three things. And then, if you can figure those three things out, you can figure out the other parts of the problem, if there are any. So first thing we always do is want to find out our components, right? Now this is a velocity vector going up to the right at 22 degrees. It's just combined velocity, right? It's x and y combined to give this angle. So we want to find the components, the x part, vx, and then the y part, vy. All right, so we do that with our calculator using SOHCAHTOA, which we've gone over, I think everyone's good with. So we just do 27, sine of 22, and we're going to get 10.1. That's going to be our y component there, because SOHCAHTOA, so is the opposite side, and then ka for CAH cosine, so we do 27 cosine 22, and we get 25 meters a second for the x component. So if you want to find out how long it's in the air, I'm gonna draw a picture, a very bad picture, I'm sure, up, and then it comes back down, and we're going to assume that this projectile lands and is launched from the exact same height. So its highest point is somewhere in the middle here, exactly in the middle actually, and we know that the y component of velocity is 0. All right, now remember, everyone needs to. Some people are better at this than others, and some of us it takes longer, and that's okay to kind of understand these concepts. But we got to keep in mind that as this projectile is going, it has some y component of velocity going up and some x going to the right, and the x component is constant, right? Its x component is always going to be that 25 in this problem. It's always going 25 the whole time, even right as it lands. But the y component starts off large, but then it gets a little smaller and a little smaller and a little smaller, and then it's 0 here, and then it goes down and down and down, and then 3 and kind of mirrors. This side kind of mirrors that side, right? So we want to find out how long it's in the air for. If we use this spot here, we say, okay, we know y velocity here. Vy there is 0. We know Vy naught is here, and then that's plus at. That's one of our basic kinematic formulas. Notice that we have to keep everything in the y direction, right? This is Vy, A, acceleration. There's only one acceleration here, and that's in the y direction. There is no acceleration in the x direction. All right, it's constant velocity. Look, it doesn't change, right? Same. We're only accelerating in the y direction, so we use A. We have to use A to solve for y direction stuff. So we use our equation. This is the equation we're going to use to find out how long it's in the air for. Almost always, this will be at least part of the problem. In the other video I did a little more complicated problem, and we got to use this plus another formula. So you should watch that video too. Anyway, let's go ahead and solve this. So Vy here, this is final y velocity, right? It's 0 at the spot. It's our final, that's what we're going to. So that's 0 equals Vy naught, velocity in the y direction initially, we said was 10.1, plus A, now that's negative 10, because that's acceleration is always down, and down is negative, and then t, the thing we're looking for. So we just move this over here, negative 10.1 equals negative 10t, and we divide by negative 10, and we get t equals 1.01 seconds. And then to find the whole time, remember that's only to here, right? We want the whole time. We're going to go ahead and do double that, t times that times 2, so we get 2.02 seconds. That's our total time, right? Once we have this part here, how far it goes is super easy, because how far it goes, how far is this way, right? It's horizontally. And again, there's no acceleration in the horizontal direction. It's only, in the horizontal right, it's only constant velocity, rather. So no acceleration, we can use our easy formula, V equals xt, super easy. And again, we got to keep everything in the same direction. We can't use our y velocities here, and we can't use the combined. That's also, this is a combined velocity. We can't use y, can't use combined. We want to use only the x. This part here, this 25 meters a second, that's what controls how far it goes this way. That's all we care about for horizontal, for the horizontal part of the problem, is the horizontal information, which is velocity horizontally is here. So we plug in 25 there. We know our total t now is 2.02. So we plug that in, and we just, I didn't realize this. I messed this formula up. This formula is wrong. It should be x equals vt. Sorry about that. Hopefully y'all caught that. And luckily I did too before I solved it. But it's x equals vt. That's the formula we want. Sorry about that. Anyway, you plug in the velocity here for v, time there, total time for t. We just multiply them together, and we get 50.5. And that's meters, right? That's how far we go. That's x. That's a horizontal position, right? That's how we are changing position this way, how far we went. And lastly is how high. For how high, we can't use this equation, right? We can't use x equals vt. Can't use that one because this is for horizontal only. It doesn't work for vertical, okay? Because in the vertical, we have an acceleration. As an acceleration is non-existent in this formula, so we can't use it. So we got to go to our old equation y. Y equals y naught plus vy naught t plus 1/2 a t squared. There we go. Now this one we know everything we need to know at this position except for the y, right? Now y is just like x, it's position, but instead of this way, it's vertically up and down. So y will be our total height, final position. Y naught is our initial position. We started on the ground, so that's just 0. Vy naught, our initial y velocity, is 10.1, times t. Now our t here, we're not going to use this t because that's the total time from the very beginning all the way to the end. We know how high the object is at the end. It's 0. That's something we want to find out how high it is here. How long did it take to get here? Well, it took 1.01 seconds. So that's a t. That's the time we're going to use. 1.01 plus 1/2 a. That's -5, right? And then times t squared was 1.01 squared. And that's going to equal our final height y. So we do all the math here. Plug it in. 10.1 times 1.01. Let's see, minus 5 times 1.01 squared. And I got 5.1 meters. So 5.1 meters is how high it goes. Let's see now. Every time we get an answer, we should always ask ourselves, does this make sense? Well, 22 degrees is fairly flat. This isn't going all that. It's 27 meters a second is pretty fast. Not that fast. You know, it's about as fast as you throw a baseball, maybe. But this angle is pretty low, so we should definitely be going farther horizontally than we are going high, right? If the angle was like 60 degrees, that's like almost straight up, right? Then our height should be pretty high, and our horizontal position should be pretty short. But this seems reasonable. Our horizontal displacement is 50. We only go 5 meters up in the air. Seems reasonable. So there you go. These are the basics, right? So make sure you guys understand about how the x and the y kind of act together. How you got to keep them separate. How to use the formulas. And I'll see you class on Monday. Have a great weekend.